Our penultimate speaker is Michael Freyny, Executive General Manager, Siemens, Australia. Thank you.
Okay, so taking the words of my predecessor, now somebody else is up and speaking. So, what I would like to do is in the next 10 minutes also to speak about Industry 4.0. And I think some of you guys might have said, well, probably that's the 5th time we hear about it. But I want to take a little bit of a different approach and more talk about applications and how we as Siemens think about Industry 4.0. Before, and it was also touched by a couple of the presenters before, why is industry important for a nation? Why don't you say, well, the focus could be service society, like the US did, and when 2008 came, roughly 9% of the GDP was done by manufacturing, only 9%. And I think in 2008, during the crisis, they didn't do that well. So after that, they made an analysis and said, well, what are the countries that went through those crises fairly okay? And they looked at Germany, for example, and Germany's contribution to the GDP is 30% by manufacturing. So 1/3. And that's when they started their, what we call their manufacturing renaissance. A little bit different twist, in the sense of more focusing on energy-intensive industries and providing cheap energy. But that's what they did to improve and get balance into their society. China, very well known for producing manufacturing, being the workbench probably for the world. They are taking a very hard look in how to improve manufacturing, in particular when it comes to quality. How do we stay competitive? If you go to Shanghai and you want to hire an engineer, well, I would say that engineer is roughly cheaper than in Australia, because cost of living in the western part of China have gone up tremendously. So they need to look at new ways how to get efficient and save cost. And Japan, I think, is another example, known for very long tradition on manufacturing, and they are not a lead cost country either. So you draw your conclusion, but I think if some of those countries really take a hard look in how important manufacturing is for society in those countries, I think it's a no-brainer and no question how important it is for Australia. What look take we as Siemens, and what step approach do we take to come to Industry 4.0? Well, we for ourselves, and I think we have many manufacturing sites in the world, we also look at the same, like Weidmuller was saying in the morning, in how do we adapt those standards? How do we get there? And step number 1 for us is making sure that we have good implemented MES, management execution systems, and ERP systems. Making sure all data is real-time available for management to make decisions. I was really impressed in the morning with one presentation where one was saying, well, you know, we have a failure in a plant in the UK, and 50 minutes later I get the call from the US. I think they have definitely made step number 1. And that's what we are also looking for. Some will say, well, MES systems exist for 10 years. It's nothing new, that's not new technology. I agree. But the amount of data that's available today and the integration possibilities that you have are vastly superior now. Have you integrated your partners, your suppliers? Have you integrated your stocks, your logistics? All that we consider under step number 1. Step number 2 is digitalization. And I think we heard today enough about digitalization of a product and design development, but also digitalization of your manufacturing equipment. Why that? Well, you know, once you start production, you continuously want to improve your production. And we had a customer in the food and beverage industry who wanted to enhance its throughput. And the bottleneck on the line was the packaging. So what do? You buy a new packaging machine, you just take the risk in running it 10% faster, with the risk of breaking down and have a huge production outlet. So what we did with them together is we digitized their production equipment, and we simulated what would happen if you run it 5% faster, 10% faster. And by doing that, we could identify the areas where they needed reinforcement or improvements. And with a quick fix-up, we turned out to improve the whole line production by 5%. That's why it's important not only to look at digitalization or digitization of your product, of your whole equipment in the manufacturing side. Step number 3, the logical consequence then, is bringing both worlds together. The cyber-physical world of your production, your product, with the real world of your daily data. Plus, giving the autonomous of some of the production cells to communicate with each other and making sure whom to include and whom not. Well, that's still a step away, and none of our factories has reached that step so far. But is everything fiction, or is there some real applications? And I want to just share a couple of things with you where customers have really have had huge improvements in productivity. If you look at Pratt & Whitney, for example, they designed the new jet turbine completely in the virtual world. They used avatars to make sure that the serviceability of the new jet engine would be easy, to reduce downtime and service time. By doing that, they reduced their R&D time by 50%. We heard many things about cars, and me being in Australia now for 18 months, I know that the car industry is not the strength, and it's more on the way out. But let us use more car manufacturing as high-value, mostly unique items that need to be produced. And if you have similar topics, you can relate to this industry. And Maserati was coming to us and saying, well, we want to produce a new car that takes on the likes of premium German cars like BMW, Mercedes, and Audi. And we want to do it in record time. The standard for bringing a new model to the market is around 18 months. So they adopted the same concept in designing everything in the virtual world first, even simulating the car and the car behavior in the virtual world, reducing the number of prototypes that they had to do, and in parallel, designing the manufacturing line. Again, in the virtual world first. By doing all that, they produced the first car in 15 months, which is a reduction of 30% of a normal design time for a car, which in automotive terms is tremendous. You will say, well, all good, we heard so many things about products and the importance of a product. Well, Michael, I'm producing the same product for 20 years because, I'm in process industries. I'm producing a gas, I'm producing ore. So, all the nice features that you have as designing a product are not applicable for me. So is there anything that I can benefit from Industry 4.0 and digitalization? Just one example of an oil and gas platform, which we designed together in the virtual world first. It was an oil rig in front of Africa, and by using a 3D walkthrough, and people will say, well, 3D walkthrough we had 10 years ago. I agree with that. But could you use the same data that you had for the CAD design to simply come up with a 3D walkthrough? I doubt it. And by using that and implementing that, the production could start 6 weeks earlier, which again, with a high-value item in a process industry, is quite some significant advantage. And even simple things like the surfboard. I think many of you in Australia that use a surfboard probably know the company. That's an Australian company. They use digitalization to customize the sports equipment. You can define the design. It is going to be done as per your requirements. Simple applications. It doesn't have to be always high sophisticated. Digitalization Industry 4.0 has many facets. So why do we say you need to look at all the areas of the life cycle of a product? I think we're all clear there is advantages when you come to the design of a product. I think all of us know right now there is benefit using digitalization by designing your manufacturing site. Why do we look for production and service? I think production, I mentioned, to continuously improve your efficiency. Because again, those old rules, once you start manufacturing, you have to continue to improve. Don't stop with digitalization and Industry 4.0. What about the serviceability? I have seen many sites, even in my 18 months, where customers using IT technology and sophisticated programs to run the inventory management. still, they suddenly come to us and say, well, you know, we have misplaced a part and we would need a spare part. What has happened? They bought spare parts, and on a mine site oil platform, some of the equipment that you have has spare part cycles of 15, 20 years. And there's no connection between the storage facility and actually the equipment where it's needed. They have no idea when there is a next service. So when they run asset optimization and asset write-off, they are saying, well, you know, this part is sitting here for 10 years. Let's call the scrapper and sell it to him, without knowing actually that this part might be needed for a service in 15 years. That's why it's so important that the digitalization needs to be run through the complete life cycle of a product. Look at where Australia is investing right now in the defense industry. Submarines. They have a life cycle of 30 years. How do you make sure that, you know, generations of people that are working on have almost instantly the information, which component is there, when was it last serviced, what is the replacement part, where do I find it? That's why I'm saying, or we are saying, digitalization is not only starting on the product and the design, it's important over the whole life cycle of the product. Well, some of you, again, might say, you know, I'm in production already, I don't have those high fancy components, I'm not willing to set up a new plant. How can I use my existing setup to benefit from digitalization Industry 4.0? And I think, again, it was mentioned that data plays an important role in that. And I give you a couple of ideas and how much data we produce. But before we do that, I was looking up how much data is going to be available by 2020 in the data universe. And they were talking about 44 zettabytes. Has anybody an idea what a zettabyte is? I didn't have myself, and I was looking it up, and it's 10 by the power of 21. And I think we're all probably familiar with terabytes, which is 10 by the power of 12. So just to give you an idea of how much more data is available. And to be honest, all the data that is available today, how much is going to be used, or how much is used? Roughly 10%. 90% nobody's looking at. And giving you a couple of examples what we as Siemens generate per data and some of our equipment, a steam turbine, 25 gigabytes a day. We have a smart energy platform, 30 gigabytes a day. A Siemens computer tomograph, obviously a well-used one, 60 gigabytes a day. And finally, something like the particle accelerator in CERN, 100 gigabytes a day, the amount of data that's going to be produced. So you can do many things with that kind of data. What do we do? Just to give you one example. We do service for gas turbines for 30 years already. So how do we enhance with the availability of data, our service, and the customer experience? I mean, gas turbines and gas plants are very often used for a long period of time. As I said, 30 years. But you never know the usage in advance. So in the old world, we had continuous maintenance intervals in a regular time frame. Well, in the new world, with the availability of data, you can say, when do we need to do a service? You go for predictive maintenance based on the usage of the gas turbine, which also helps the customer with saving cost on service, on the other hand side, improving uptime. So these are the capabilities already in front of us, that we don't have to wait. We should move now. That leads me to my last slide, and saying, well, you know, why do we do all this Industry 4.0? And the driving force is always productivity. Always productivity. And creating value by doing tasks of improving the value of a company's offering and the willingness of the customer to pay is a business model, is the foundation of every business model. Creating value for product companies has usually been looking at what's driving the customer, what's their apparent needs, then designing and manufacturing a very high quality product. Competition was more based on feature-to-feature warfare, and when innovation became incremental to the features, price war kicked in. I think that's a model that we see for the last 250 years, since the Industrial Revolution, and you can see it every day in your either department store or the electronic supplier around the corner. But in the connected world, a product sale is not anymore a one and done. We have the opportunities for over-the-air updates of functionality. We can monitor the performance and the behavior of our products in use. We can adjust to customer behavior. We can link information together, and by that come to new productivities and a new service experience. That's where the strengths of digitalization Industry 4.0 is, and it's there today. And if you forget everything that I said today, I just want to tell you three things that you should keep in mind. Identify for yourself what's your potential for digitalization. What is your digitalization potential? Define how your infrastructure for digitalization and the tools should look like. And make a good choice on who is your digitalization partner. Thank you very much.